Okay, so here we have the Wikipedia page for the Ikasi Dodecahedron, and it's actually got a lot of really neat descriptions and various different ways you could picture it, including these interesting wireframes and duals.
Yep.
But the most interesting thing we're going to take a look at here is there's a there's a formula for the area, the surface area, and the volume in terms of the side length, a cubed.
Okay.
So there's actually a very straightforward, surprisingly straightforward volume calculation.
Yep.
45 plus 17 times the square root of 5 over 6. And that square root of 5, is that surprising to you that it's in there, or is that not surprising it's in there to you?
Well, since the side length is based on the ratio of the side length is based on the golden ratio, so I think it should have something to do with the golden ratio.
Yeah, it's interesting because if you can build something with the blues that has that golden ratio in it, so not a cube, which you can build with the blues, but you can build pentagons with the blues, so the square root of 5s tend to show up when you have pentagons. And then I found this other interesting website that actually gives the formula for the radius of the circumscribed circle right there, which is a over 2 times 1 plus the square root of 5, which is exactly what we found.
Yes.
So that's going to allow us to do a calculation where we can say if you had that radius, if you had that side length, we can calculate the volume of the Ikasi dodecahedron. And if we had that radius, we can calculate the volume of the sphere.
Yeah.
That has that same radius, and then we can do the ratios.
All right.
So, somewhere, I also have up a Mathematica spreadsheet. It's not the Mathematica spreadsheet, a Mathematica workbook. That's probably not even in the screen. How do I make this bigger? I might have to pause for a second. Where do I zoom in on that?
Do I make it? Yeah, unfull screen it and then.
There it is. Yep. Yeah, unfull screen it and then let's go to 200% and maybe I'll just move this to the middle. Okay, so there we go. So I just made the side length 1. Here's my volume.
Yep.
There's my radius. Now, do you know the formula for the volume of a sphere?
Yeah, I think it's 4/3 pi r cubed.
Yep. So that's my ratio here. So the volume divided by 4/3 pi r cubed, and then n is going to tell us exactly what that is. So you think it was 90%? That was your guess.
Yeah, 90%.
All right. Let's evaluate here.
We get 78%.
Yeah, so not quite a sphere, but nearly a sphere. We could even do some fun calculations if we wanted to and see what, pi would be. If the formula was going to be 4/3 pi r cubed, what would pi be for the Ikasi dodecahedron? We could calculate that. Do you know what I mean?
Not really.
Well, let's say I wanted to get my volume being 1/6 times 45 plus 17 root 5, and I wanted that to be 4/3 pi times r cubed. I could solve for what pi would have to be.
Approximation for pi.
Yeah. But anyway, so we found it's just under 80%,
Alright.
which is interesting. Actually, it means there's a lot of volume outside of the circumsphere has a lot more volume than you think just by looking at it.
It's got about 1/5 of the volume of the sphere is outside the.
1/5 of the volume is outside. Yeah, that's a good way of thinking about it. All right, good job, and this is interesting to explore. It'd be fun if we could figure out how to do this calculation for the other shape. Though I think it might be a lot harder.
Yes, it doesn't be surprised if there's a formula for the area of that.
Yeah, I would be too, but maybe we could find it. But,
all right.
But I don't know what it is right now, that's for sure. But okay, good job, hon. Good job.